Good morning everyone. I am Trupti Arun Bhange, second year CSC department, roll number 265 from Sri Siddheshwar Women's College of Engineering, Solapur. Today I am going to discuss on topic deadlock avoidance. Deadlock avoidance. Deadlock avoidance ensures that a resource request is only granted if you won't lead to deadlock, either immediately or in the future. Since the kernel cannot predict future process behavior, it uses a conservative approach. Each process declares the maximum number of resources it may need. The kernel allows request in the stages, checking for potential deadlocks. Before granting them, a request is granted only if no deadlock is possible. Otherwise, it stays pending. This approach is conservative as a process may finish without using the maximum resources is declared. Do not grant resources request if these allocation have the potential to lead to the deadlock. Deadlock avoidance can block processes for too long. Banker and safety algorithm is used. Banker algorithm is a technique used for deadlock avoidance. Maximum requirement of each resources must be stated in advance by each process. The deadlock avoidance algorithm dynamically examine the resource allocation state ensure that there can never be a circular wait condition. Advantages of deadlock avoidance. First one is a dynamically allocated resources to avoid deadlock, leading to efficient resource utilization. Second one is provides a flexible approach that adapts to the current system state. Disadvantages of deadlock avoidance. First one is requires knowledge of future resource requests, which may be which may not always be available. Second one is may lead to blocking processes for extended periods while ensuring safety. Banker's algorithm. Banker's algorithm is a resource allocation and deadlock avoidance algorithm that tests all resource requests made by processes. It checks for the safe state and if granting a request keeps the system in safe state, the request is allowed. However, if no safe state exists, the request is denied. Input to banker's algorithm. First one is a max needs of resources by each process. Second one is a currently allocated resources by each process. Third one is a max free available resource in the system. The request will only be granted under the below condition. If the request made by the process is less than equal to max needed for that processes. Second one is if the request made by the process is less than equal to the freely available resource in the system. Bank would never allocate its money in such a way that it can no longer satisfy the needs of all its customers. The bank would try to be in safe state always. Why bankers is used? It's based on the analog of a bank leading resources to customer without running out of funds. Problems on banker algorithm, that is, consider the following example of a system checks whether the system is safe or not using banker's algorithm. Determine the sequence if it is safe. Here we have given processes P0, P1, P2, P3, P4 respectively. Allocation matrix have given and maximum demand matrix have given. Then solution is a processes P0, P1, P2, P3, P4 and allocation matrix and maximum demand matrix are given. For finding need matrix, we have no formula. Need is equal to max matrix minus allocation matrix. So we can write 7 minus 0, that is 7, 5 minus 1, 4, 3 minus 0 is 3. Then next for process P1, 3 minus 2 is 1, 2 minus 0 is 2, 2 minus 0 is 2. For process P2, 9 minus 3 is 6, 0 minus 0 is 0, 2 minus 2 is 0. Then next one is for process P3, 2 minus 2 is 0, 2 minus 1 is 1, 2 minus 1 is 1. For finding P4, 4 minus 0 is 4, 3 minus 0 is 3, 3 minus 2 is 1. For finding available, we have formula available is equal to total resources minus allocated resources. We have total resources, that is A equal to 10, B equal to 5, C equal to 7. So calculate allocated resource. For A is equal to sum of all these, 0 plus 2 plus 3 plus 2 plus 0, that is equal to 7. For B, sum of all these, that is equal to 2. For finding C, calculate sum of all these, that is equal to 5. For finding available, we have formula, that is total resources minus allocated resources. Available is equal to total resources are A is equal to 10, B is equal to 5, C is equal to 7, that is 10, 5 and 7, minus allocated resources. We have find allocated resources, that is 7, 2 and 5. Here we can write available is equal to 332. Apply banker's algorithm. Here we know formula of need is less than equal to available. That is available is equal to available plus allocation. Our process P0 need is 743 and available is 332. 743 is less than equal to 332. In this condition, we cannot proceed. For process P1, need is 122, available is 322. 122 is less than equal to 322, so can proceed. Available is equal to available plus allocation. For finding available, we have this formula, available plus allocation. Here we have available is equal to 332 plus add allocation for this need 112, that is allocation is 200. Add 200 in 332, that is equal to 532. Then available is equal to 532. For process P2, we have need is equal to 600 greater than equal to, here updated available is 532. So here condition is 600 is greater than equal to 532. So condition cannot satisfy, then cannot proceed. Then for process P3, here need value is 011 less than equal to 532. 011 is less than equal to 532. Can proceed. Available is equal to available plus allocation. So here available is 532. For process P3, allocation matrix is 2 1 1. Add 532 plus 2 1 1. So available is 7 4 3. This is updated available. For process P4, need matrix is 4 3 1 less than equal to available 7 4 3. 431 is less than equal to 743. Condition is satisfied, so can proceed. Available is equal to available plus allocation. Here available is 743 plus allocation for process P4 is 002. Add 743 plus 002. Available is equal to 745. Updated available is 745. So for process P0, need matrix is 743. 743 is less than equal to 745. So condition is satisfied, so can proceed. Then available is equal to available plus allocation. Here available is 745 plus allocation for P0 is 010. Add 745 plus 010, that is 755. Updated available is 755. For process P2, need matrix is 600 less than equal to 755. This condition is satisfied, so can proceed. So available is equal to available plus allocation. Here available is 755 plus allocation for P2 is 302. Add 755 plus 302, that is 1057. Updated available is 1057. Shape sequence of given system is P1, P3, P4, P0, P2. The given system is in the shape state. Thank you.